Components of soil. Soil is the substance that forms the top layer of the Earth's crust. This makes soil the basis for plant growth. Plants rely on the soil for nutrients. Water and minerals are taken in through the root system and transported throughout the plant so that it can grow. Soil has 4 components: air, water, organic matter, and minerals. You might not have thought about air and water as part of the soil, but in good soil, they make up about half, about 25% each. Air and water fill up the pore spaces between soil particles. If soil has either too much water or too much air, it can be detrimental to the plants growing in it. In case of heavy rains or over-irrigation, water may fill up all the space between the soil particles and force air out of the soil. If the water can't drain, the soil stays soggy. Most plants can't thrive in soggy soil, so they begin to turn yellow and stop producing. Plants need a balance between water and air in the soil. Organic matter is plant and animal remains that have decayed, and it's full of nutrients. In an advanced stage of decay, organic matter is called humus. Soils high in humus are dark in color, loose, and fertile. Most soil contains no more than 5% organic matter. The other 45% of soil is made up of minerals. Minerals are inorganic elements that naturally occur in the soil. Minerals come from weathered rocks and other materials that have eroded and deposited over the surface of the earth, as sand, silt, and clay. Sand is the largest mineral particle. Because sand particles are so large, there are bigger spaces between the particles, so sand allows water to drain quickly. Sand has more air content because the water drains so quickly. Silt is a mineral particle that's smaller than sand. Silt can fill up the spaces between sand particles and increase a soil's water retention. Clay is the smallest mineral particle, even finer than silt. Clay particles can fill up the spaces between the silt and sand in a soil and further increase the soil's water retention. However, a soil that has too much clay content will have poor water drainage and not allow enough airspace. And now, let's explore the core. A farmer wants to plant corn on a recently purchased piece of land. He needs to determine the texture of the soil, because corn yields a better crop when grown in a silty soil than it does in a sandy soil. The farmer performs the following exercise to determine proportions of sand, clay, and silt. He fills a jar 1/4 of the way full with 5 inches of crushed soil. He adds water until the jar is 3/4 of the way full, and then adds a teaspoon of dishwasher detergent. After tightly fixing the lid onto the jar, the farmer shakes the jar for 15 minutes. He then sets the jar down and waits for soil particles to settle. After 1 minute, the farmer checks his jar. Sand particles are the first to settle. He marks the depth of the settled sand particles on the outside of the jar with a marker. Silt and clay are less dense, so they take quite a bit longer to settle. While the farmer waits, let's talk about what's happening here. The soil and water form a suspension, which is a mixture that looks uniform when shaken but separates into different layers when at rest. As the soil mixture settles, the contents at the bottom of the jar aren't the same as the contents at the top of the jar. This type of mixture is called a heterogeneous mixture. Let's check back with the farmer. After 2 hours, he marks the next settled layer, the silt. The farmer will have to wait even longer for the tiny clay particles to settle, so he decides to make a pitcher of lemonade from a drink mix packet. He stands back and compares the two mixtures. How is this lemonade solution different from his suspension of soil particles? Unlike the farmer's suspension of soil particles, his lemonade solution is a mixture of 2 substances that have a uniform composition. A solution is a homogeneous mixture because it is the same throughout. The sugar, the solute, dissolves in the water, the solvent, and won't settle out if the lemonade sits on the counter. In the end, the farmer waits 2 days for the water to clear, and then he marks the 3rd layer of settled particles, the clay. He uses a ruler to measure the thickness of the sand, silt, and clay layers. The thickness of sand is 1/2 inch. The thickness of silt is 3 inches. And the thickness of clay is 1.5 inches. He adds these to get a total thickness of 5 inches of soil. From this total, the farmer can calculate the percentage of sand, silt, and clay that are in his soil. To get percent of a whole, he knows he needs to divide the part by the whole and multiply by 100. Starting with the sand, he takes the thickness of sand, 0.5 inches, divides by the whole thickness, 5 inches, and multiplies by 100. His soil is 10% sand. He does the same for the silt and clay. His soil is 60% silt and 30% clay. Now the farmer uses the calculated percentages and a textural triangle to find the texture of his soil. The farmer locates the 10% sand line on the bottom side of the textural triangle and then follows the line until it intersects the 30% clay line. Notice that the 60% silt line also intersects at this point. The intersection point of the 3 lines is in the silty clay loam area of the triangle, so the soil is a silty clay loam. The farmer will definitely plant corn on his new piece of land. Today's SAT word is detrimental. Detrimental is an adjective that means damaging or causing loss. In the lesson, we learned that too much air or water in the soil can be detrimental or damaging to plants.